This is a video lesson for What are Forces. In this video, we are going to learn about different types of forces, how to identify them, and how to describe how they work. So what are forces? So forces are when two or more objects interact. A force is a push or a pull resulting from that interaction. So a push or a pull resulting from that interaction. When the interaction stops, the forces also stop. So the units for force are the Newton, which is kilograms meters per second squared. So the Newton is, we write a capital N, and it's kilograms meters per second squared, which is going to make a lot of sense when we see how we actually calculate newtons or how we calculate force later in the unit. So let's talk about the types of forces. So there are two main categories of forces. The first are contact forces. The second are non-contact forces. So examples of contact forces are the normal force. So this is the force that exists when you are standing on the floor. You push against the floor with your feet. So you're pushing down with your feet, and the floor is pushing back on you. So this is the normal force. You're pushing down, and the floor is pushing back on you. That force pushing back on you is the normal force. There's the applied force. So that force is just kind of a generic force, a catch-all force for anything that doesn't have another name. And then we have the tension force. So this is a force that is applied or that is mitigated through a rope or a chain or something like that. So the force is through a rope or a chain. That's the tension force. And then we have examples of non-contact forces like gravity. That's the one that we're going to use most often in this class. We also have the electromagnetic force. So that is electricity and magnetism. And then we have the strong and weak nuclear forces. And these forces are what hold the nucleus of an atom together, so protons and neutrons. And then they are what hold actually protons and neutrons themselves together. So they're what hold the quarks that make up protons and neutrons together. All right, forces or vectors. So we need to know two pieces of information. Two pieces of information about a force. We need to know the size of the force, or its magnitude. And we need to know the direction of the force. So forces then are vector quantities. Let's talk about a sum of forces. So because they're vectors, we can add up all the forces acting on an object separately, and we'll do so in each direction. So for the y-axis, up is positive and down is negative. And on the x-axis, right is positive and left is negative. And we use this symbol, sigma F, to denote the sum of forces. We can also think of it as F net, which is the net force. And these two are synonymous with each other. So the sum of forces equals F net. And if we look at this diagram over here on the right, we have this force vector to the left with this tug of war going on. So the blue team is pulling to the left. They have this amount of force. And then we have the red team to the right pulling to the right with this amount of force. So you can see the force is much greater to the right than it is to the left. And when you add the right, you end up with a sum of forces, which is less than the rightward force by itself, because you're subtracting some of this leftward force, but it's still greater to the right than it is to the left. So you still have a rightward sum of forces rather than a leftward force.